Hello class, today we'll be starting a new unit on quadratic functions. And what we will be doing to begin is exploring the graphs of quadratic functions. This lesson, in which we're exploring graphs, will be divided into three parts. Today we're going to complete part 1, which is understanding vertex form. Our learning target is I can identify key characteristics of the graph of a quadratic function. And again, we'll be focusing on examples that are given to us in vertex form. So before we get into some examples, we need to talk about what these vocabulary words are so that we can identify what are the key characteristics of quadratic functions from vertex form. So a quadratic function itself is an equation whose largest exponent is 2. And we've talked about that several times this year. That should be familiar territory for us. So we're looking for a function form, f of x, where you have x's in the equation, and it has a highest exponent of 2. So there's no exponents of 3 or 4 or anything higher than 2, and there has to be an exponent of 2. So you may have x squared plus x plus 1. That would be an example of a quadratic function. Okay, the second word is a parabola. A parabola is the word that we use to describe the shape of the graph of a quadratic function. And we say that parabolas generally smile or they frown. So what does a parabola then look like? Well, on a graph, a parabola looks like a U that is either opening upward or downward. Again, we sometimes refer to these as a smile or a frown. The next word, vertex. The vertex is the highest or lowest point on a parabola. So when we're talking about all the points contained on this parabola, the highest or the lowest point is called the vertex. So here is the lowest point, that is the vertex, or if it's frowning, it has a highest point, that would be considered the vertex. So that's an ordered pair. A vertex has an x-coordinate and a y-coordinate. The next word, axis of symmetry, is the line that divides a parabola into two mirror images. So if I, again, examine a parabola and put my vertex on it, the axis of symmetry is a vertical line that actually goes through the vertex that creates two mirror images of each other on each side of that line. There is a formula for calculating the axis of symmetry. X equals negative b over 2a. And we will be using that formula a lot in this lesson. Well, in this unit. Also, I will mention that the axis of symmetry, x equals this formula, that gives us the x-coordinate of the vertex. This x-coordinate of the vertex is also the axis of symmetry. Okay, so when we talk about quadratic functions, there are two different forms that we're going to be studying. The first form is vertex form, and that's what we're going to focus on in this lesson. So you'll see that in vertex form, we see our function notation. We have parentheses, x minus h squared plus k. Our vertex can be found, this is called vertex form, because the vertex can be found by looking right at the form that's given. This h and k are the coordinates, the x-coordinate and y-coordinate of the vertex of the quadratic function. I do want you to make note that there is a sign change from this minus h to the vertex ordered pair. So if it says minus 3, the x-coordinate is 3. If it says plus 3, the x-coordinate is negative 3. There is a sign change here, just on the x-coordinate of the vertex, and then k is the y-coordinate of the vertex. The other form that we will study is standard form. And we're not going to focus yet on standard form, but this looks probably familiar to us. ax squared plus bx plus c, where we have a, b, and c, a being in front of x squared, b being in front of x, and c being the constant term. And you'll see the formula or the procedure down here for finding the vertex when we have an equation in standard form, but that will be part 3 of these notes. Okay, so in our first example, we are asked to find the following. Find the vertex given this function. So these are all some key characteristics of the function of a quadratic function, and we're going to answer these questions for each part. So part A, find the vertex. Well, since this is given to us in vertex form, the vertex can be found by a sign change of this and this. So our x-coordinate is going to be positive 4, and our y-coordinate, we're going to keep that sign, is going to be negative 2. So our vertex of our parabola would be on the graph, on the coordinate plane, at 4, negative 2. The axis of symmetry, as I mentioned before, is always going to be the x-coordinate of the vertex. There's a formula for it, but that's when we are in standard form. So for this part, all we have to do is identify the x-coordinate as 4. So the axis of symmetry is x equals 4. Looking back at the function, I will mention that we said the parabola could be a frowny or a smiling. How are we going to know that? Well, look in the front. In the very front, we see a positive value. Positive parabolas smile. So this is going to be a smiling parabola, and negative parabolas frown. That's not too difficult to remember. So I know this is going to be a smiling parabola. I know my axis of symmetry is at 4. I know my y-coordinate of my vertex is at negative 2. So here is the ordered pair for that vertex. Since this is a smiling, this vertex happens to be at the bottom of the graph, meaning we don't have a maximum value here. We have a minimum value. Okay, this is a minimum value because the parabola smiles. And we will say that the maximum or minimum value is going to be that y-coordinate of our vertex. So our minimum value here is negative 2. Minimum value is negative 2. Next, we consider our domain. So I'm going to give you a nice little sketch now. We've got a vertex at the ordered pair 4, negative 2. We've got a parabola that's smiling. This is as accurate as I need your graphs to be right now. I need to know where the vertex is and then know if it smiles or frowns. This is smiling. For domain, we've talked about the fact that domain means x's. So it means smash the graph so that it flattens out on the x-axis. So if I were to compress this graph so that the arms of that parabola lay flat on that x-axis, I will see that these arrows would completely lay down and it would cover the entire x-axis. So our domain, we can say, is all real numbers, or negative infinity to infinity. And that is going to be the case for all parabolas. The range is not quite as easy. You do have to do a little bit more thinking. The range is when we take this parabola and we smash it flat to the y-axis. So if I flatten this all the way to the y-axis, this point will move over here. And notice that both arms are pointing upward, so they're both going to lay on, sorry, I got extra line here. They're both going to lay on that y-axis pointing upward. So this would be the smashed graph, okay? So, if that is our, so we would say that our range begins at a lowest value, or our minimum value of negative 2, -2. And then it goes upward forever to infinity. So this is one way of describing the range. Another way to describe this range is it's all the y values that are greater than or equal to -2. For example 2, we have another function. We're asked to find the same key characteristics. So our vertex, really simple. Sign change, -1. Keep the sign, 4. Axis of symmetry, that's going to be our x coordinate of our vertex. So it's x equals -1. Maximum or minimum value, well, I do want you to note that this is a negative parabola, so it's frowning. So that vertex is at the top. So we don't have a minimum this time. We have a maximum value, and that maximum value is going to be our y coordinate, 4. The domain, again, the domain is going to be all real numbers, because even though this parabola is frowning, if we lay it flat or smash it flat to the x-axis, it's just going to flatten out on that x-axis. So it's all real numbers, or -infinity to infinity. But as far as range goes, this vertex is at the point -1. Let's say this is -1, so 0 would be here. -1, 4. I better just start a new sketch. -1, 4. So -1, 4, and then it's a frowning. So if I were to flatten this thing to the y-axis, I would have a point here, and everything, both arms, will be flattened so that they're pointing downward on the y-axis. So our range, our lowest amount, start with the smallest number, would be -infinity. And we go up to the value of +4, because that is a maximum value, and it actually does hit the 4, so I'm going to use a square bracket there. Also, I could say it that it's all the y coordinates that are less than or equal to +4. So I hope that this helped you with understanding what vertex form is. And I hope that after this short video, we can feel confident in identifying the key characteristics of the graph of a quadratic function from vertex form. Good luck on your assignment.